We are ready for 1C, the flagpole problem. So all these word problems, remember the directions. The directions say, draw a picture, write an equation, solve it. And round to the nearest hundred. All right, so how tall is a flagpole? So we're going to draw our flagpole. Here's your right angle. Remember all of these pictures that you draw, worms on the ground, birds in the trees, seagulls on the lighthouses, all these have right angles, right triangles. How tall is a flagpole? It casts a 23-foot shadow when the angle of elevation of the sun is 32 degrees. All right, so where do I put the 32 degrees? Right here. Yang, your angle of elevation, angle of depression always goes right here. We're never going to get confused. That's where we put it. We'll never be wrong. Now, where do I put the 23? Be careful. Cast a shadow 23 feet long. So where do we find the shadow? Down here, right?
Yeah.
The shadow's on the ground. So there's the picture. Now you got to write an equation. And the equation you write will always be sine, cosine, or tangent. So kind of look at the setup here. What do you think we've got going on? This is a tangent problem. We know it's a tangent problem because this is opposite and this is adjacent. So tan 32, remember, as soon as you decide tangent, you know it's going to be tan 32. The angle always goes with the function. So tan 32 equals x over 23. Need to solve it now. So I'll So x equals 23 tan 32. Make sure your calculator's set in degrees because that is a degree measure. So always double check that before you start. It only takes a second. So 23 tan 32 rounding to the nearest hundred. Did you get 14.37 feet? Is that okay, friends? All right. Now, the next one is draw only. Now, when we get to the next chapter, we will be actually working on problems like this, but right now we're drawing them only. It's just draw only. So here it is. Draw the path of a ship. All right, so this is going to be one of those where we're using a compass heading. You remember, compass headings are a little bit different. We talked about these before. What's different about them? Yeah, these are the direction ones.
All the angles are on there.
So the angles are in a different spot. When we're doing directions, our compass is set up like this. That is not the way we do any other angles. But for direction, we have to do it this way. I wish it was all the same. It's not. I didn't make the rules. We just have to live with it. This is the compass. Draw a path of a ship. If it sails for 4 hours on a course of 125. Okay, so let's stop there. 125 degrees. So that course will be down here. Would you agree with that? So here's 125. For 4 hours. Oh, wait. All right, so there's the beginning one. Is that okay with everybody? Now, he's sitting down here. So I'm going to put another compass. Now he's sitting right here. So here's my new compass at my new location. Because he's going to change position. Now he's gonna go on a course of 195. Right here. For 1 hour. Now, I'm making this, I'm not gonna measure specifically, but would you agree the red one is going to be shorter than the purple one? Because the purple one represents 4 hours, and the red one only represents 1 hour. So I'm not being super picky, but don't make them the same. Make this one shorter. Now, the ship is traveling at a constant speed of 10 knots. Does anybody know what that means? Have you heard that word before? Airplane speeds are often measured in knots. Yeah. A knot is a nautical mile per hour. So you know how when you get in your car and you're driving down the highway at, 50 miles an hour, that's a speed. A knot is a speed. There is a little bit of a difference between a land mile, they're called statute miles, a land mile, and a nautical mile. Does anybody know why there's a difference?
It's just different at sea, like the way you travel.
Why? Why is it different?
Waves. You have to count.
What?
Waves.
Well, yeah, there are waves for sure.
Well, I mean, ocean travel is just different because, like, the water. Well, you don't have wheels on a boat. I mean,
okay.
You've got an engine.
Yeah,
you
this conversation isn't going
propellers.
Okay,
Motors.
here's the deal. Knots are only used. There are no vehicles anywhere in the world. Automobiles, no automobiles anywhere in the world where the speed is measured in knots. The only things where speed is measured in knots are airplanes, space shuttles, ships, things that travel very long distances. Because our world is round. When I drive from my house to school, yes, I'm on a round world, but that distance is so small, it's a straight line. When I when I fly from my house to England, that is not a straight line. Would you agree? I am going such a long way following the curvature of the earth that it's a curve. So nautical miles are longer units than statute miles because you're following the curve of the earth. You don't even need to know that, just extra information so you're knowledgeable people.
What did you say, James?
So, we're going 10 knots. That means we're going 10 miles per hour. So the purple line is 40, and the red line is 10. And we're going 10 miles an hour for 4 hours. 10 miles an hour for 1 hour. So a knot, all you need to know about a knot is it's miles per hour. Happens to be nautical miles per hour, but it's still a speed. It's miles per hour. That's it. That's the picture that you need to draw.
It's 50. Oh, we don't even need to put a number.
What do you mean a number?
No.
Yeah.
I forgot that we're not solving.
Yeah, we're not doing anything. What we'll do in the next chapter is we'll sink right here, and then we'll have to send a rescue boat out, and we'll have to give that rescue boat directions. So we'll need to figure out some angles and stuff from that. That's what we do in the next chapter. All right, let's see if we can draw the next one. Now we got an airplane. You're gonna have one question like this on your test, okay? One. So we're gonna draw an airplane. So here we are. Here's our compass. And he's flying at a speed of 250 miles per hour for 3 hours on a course of 50 degrees. Okay, so I'm gonna draw 50 degrees. Do you agree that's 50? Now, how long is that red vector I just drew? Now look, 250 miles per hour for 3 hours.
25. Wait,
What?
3 hours.
83.33.
8 or 750.
There we go. You guys, do not make this hard. If you go 250 miles an hour for 3 hours, don't you go 250 times 3 miles? Every hour you go 250 miles. So in 3 hours you'd go 750. Don't make it hard. Now we're going to change course.
Yeah. Come on, math genius.
So now we're going to change course. Alright, so what's going to happen now? He flies at a speed of 300 knots for 2 more hours on a course of 350. Where's 350 going to be?
The same, this.
It's going to be right here, isn't it?
Oh, yeah.
Isn't that going to be 350? Because we go all the way around. This is also 360. So now he's going up here. And he's going for 2 hours at 300 knots. How far did he go?
600.
600?
No, it's 700. It's 350, right?
Okay, he's going at a speed of 300 miles per hour for
That's it.
2 more
That's
hours
350 degrees.
on a course of 350 degrees. So I drew 350 degrees, and then I marked it 600 because 2 times 300. Jordan?
Yeah, I understand. I said the 350.
So that's all you have to do. Draw the picture and we're done.
We have more space for these.
Really?
I'll give you the space you need.
Thank you.
All right, let's get our practice test out. Here we go. Notice, when you look at the practice test, it's 2 pages long. It's exactly the way your test is, 2 pages long. 1 page front and back will be no calculator. 1 page front and back will be with calculator. Okay? So we're starting with practice test number 1. I gave these to you a while back. Everybody's got one. And actually it's called pre-test. For some reason I called it pre-test instead of practice test. And this, we're doing the no calculator page. Alright, so let's see what we remember. Pre-test number 1, no calculator, change to degrees. Oh my goodness, you ought to be able to do this.
180.
So that's 180. We're going to divide that by 5. 36.
Hodor.
And then take 36 times 3. So the answer is 108. Mrs. Ford, you expect me to do it without a calculator? Yes, I do, boys and girls. We can do simple division and multiplication. I promise it's not going to be some wacky decimal. Are we okay with that? Change into radians. 250 degrees. Now we're changing that into radians. Anybody remember how to do that?
Proportion.
So we set up, so I hear both of you saying the right thing. So we're starting with pi equals 180, as Ferris said, and then we're going to build a proportion, as Jordan said. So where does the 250 go?
Under 180.
Under the 180. So my x goes here. So 250 pi equals 180x. Now we're solving for x. So we're gonna divide by 180. Get rid of the zeros and actually,
25
That's
pi
it.
over 18.
so it'd be 25 pi over 18 would be our answer. Now, sometimes this reduces further, so make sure you reduce it, but in this case it doesn't. Okie dokie, here we go. Find the measure of the arc. I'm gonna have a picture that looks like this, and we want to know the measure of the arc. If the angle is 40 degrees and the radius is 10, does that make sense to you, the picture?
Yes.
All the numbers and things look like they're in a place that makes sense to you. All right, tell me what you know.
Arc length equals radius times
Oh my gosh, Ferris, you're right. Arc length equals radius times radians. Perfect. Now I know that my radius is 10. What's the matter? The angle is in degrees, and it needs to be in radians. So aren't I gonna do what I just did over here? I'm gonna start with pi. This is like over to the side. This is not part of the answer. So pi equals 180. So what is 40? So 40 pi equals 180x. That reduces to 2 over 9, 2 pi over 9. Right?
Yep.
Now that's not the answer, don't get excited. That's the radian measure here, right? That's 2 pi over 9. So now I can find my arc length by multiplying my 10 times 2 pi over 9. So my answer is 20 pi over 9. And that would have a unit of inches. That was from before Christmas. Anybody have an issue with that? Everybody remember arc length equals radius times radians?
So remember.
Okay, number 4. This was one of our quizzes we had. We need sine, cosine, tangent. I know tangent, they told me it's 1/2. Cosecant, secant, and cotangent. So they tell me right off the bat the tangent's 1/2, which automatically means the cotangent is 2. Let's get that filled in. Those are automatic points. Now we need to draw our picture. Now, what does this mean? What does that tell me? My angle is in between 180 and 270, which means where is it? Now, this is not a compass. This is my normal measuring system. So it's going to be in quadrant 3. This is telling me where to draw the triangle. This is telling me put your triangle between 180 and 270. That means here. Now this is what's going to get you if you're not like super alert. The tangent is 1/2. Here's your angle. opposite over adjacent,
What's negative?
but they're both negative. Which doesn't matter with the tangent because they cancel out, but it's gonna matter for all the rest of these. This is important in quadrant 3. X and Y are both negative. This will never be negative, so let's find it. What's this hypotenuse gonna be, or radius, whatever you want. Square root of 5. Remember when we square, we do not take into account the negatives disappear, so this is 4 plus 1, square root of 5. Here we go. What's the sign? There's your angle. What's the sign?
Negative root 5 over 5.
Okay, you rationalized already, it's negative 1 over root 5, which is negative root 5 over 5. But when I flip it, I'm gonna flip it in this form. What does the sign go with? Cosecant, so it's gonna be negative root 5. Cosine, negative 2 over root 5, or negative 2 root 5 over 5. Does anybody have a question about that? Everybody okay? So far, I don't think this is gonna be too hard. Let's see what's next. Find the exact value. Okay, what do you, there it goes over this too. What do you remember about this? Negative degrees, okay, so, pi is 180 divided by 4 is 45 times 3, 135. Now, because I've graded so many papers over all these many years, I kind of know where the mistakes are going to be made. Don't stop here. Sometimes kids do that much, which you need to do, but then they stop. They think I'm done. 135 is not the answer. We need to find the cosine, which means we need to draw our picture, build our triangle, and find the sides of that triangle. All right, so 135 is the first step, but it's only the first step. You have to keep going. So what can you tell me about this angle right here? 180 minus 45. Well, 180 minus 135, it will be what the angle is, which is 45. This is a 45.
45.
So the sides are 1, 1, root 2.
Negative.
And very good, because that's another place that a mistake is commonly made. We forget about negatives. Remember, if you're drawing your triangle anywhere but quadrant 1, there'll be something negative. Don't forget, you're going to have negatives if you're not in quadrant 1. Now, what's the cosine? Adjacent over hypotenuse, or x over r, whichever way you want to think about it. It's negative 1 over root 2, or negative root 2 over 2. Did you follow all the steps to that problem? Because now you get to do another one. Now you get to do tangent 5 pi over 6. So, Mr. Hankins, what will I do first?
So it's 150
Okay, wait, you're right. Let's stop right there. So he did 180 divided by 6 is 30 times 5 is 150.
Are you sure that's not 300? Oh wait, no. Yeah, you're right. Sorry, it was a long night.
Plus traffic was bad on 69.
Make it public.
Alright, here we go. Regular measuring system, we only use that other one if we're doing directions. So 150 is again over here in quadrant 2. How big is my reference angle this time? 180 minus 150, so it's 30. 1, 2, root 3. Negative on the root 3. Tangent. What's tangent? Opposite over adjacent or y over x. So it's 1 over negative root 3 or negative root 3 over. Uh-oh. Sine pi. Now I know that's sine 180. Why am I saying uh-oh?
Because it doesn't make a triangle.
It doesn't make a triangle. So when you have one that doesn't make a triangle, here's your angle right here, 180. You have to use x, y, and r. So we're just automatically letting r be 1, which automatically means this point then, here's the origin, we're coming left 1. What is this point? Negative 1, 0. So x is negative 1 and y is 0. Sine is y over r. So for us, y over r would be 0 over 1, which is 0. Everybody keeping up? Okay, one more of these, it looks like. Secant 5 pi over 3. Now this is a secant, so we're going to have to pay attention to that. But first let's find our angle. Let's see, that would be 180 divided by 3, 60, times 5, 300. That one's 300. So 300 is clear over here, right? Now let's not mess this up. Pay attention. This is the angle you want. It's the angle between 360 and 300. So how big is it? 60. So root 3, 1 and 2. Any negatives? Should be. I'm not in quadrant 1. Root 3 is negative. Never make this negative. Okay, here we go. Secant. Secant is the reciprocal of the cosine. Cosine is adjacent over hypotenuse. So I need hypotenuse over adjacent, which is 2 over 1, 4, 2. Gosh, page 1 done already. You feeling okay about this? Dang. Okay, let's, what is going on here with problem E? What is this problem? What'd you say? Exactly. Find the angle. whose sine is negative root 3 over 2. How many answers does this problem have? Two. And I even marked on the test, because I'm the nicest teacher in the world, next to the problem it says 2 answers to remind you. Now, first decision you have to make, kids, is where will you find those angles? So you got to think about this. The sine is a negative number. Sine is y over r. Where is y negative? You need y to be negative. Where is it negative? Quadrant 3 and 4. Isn't y negative down here? So you've got a triangle here and a triangle here. They're both the same size, so you don't have to label everything in both of them, but you have to know you've got one in each spot. The sine, here's the angle. The sine is negative root 3 over 2. Based on that information, can you tell me how big the angle is?
60.
60. That's a 1, right? So this would be 60. It's actually a negative 1, but it doesn't matter. What you care about is the angle. Can everybody see that angle 60? And so would this one be 60. 60 is not the answer to the question. This is the answer to the question. Come all the way around to the angle line, to the hypotenuse. So what would that answer be? Think about it. 180 plus 60? So 240 is one answer. And the other one is all the way around here.
300.
It would be 300 because it's 360 minus 60. Very, very good. The test only has one of these on it. There's 2 on the practice, so we're going to practice a little extra here. Find the angle whose cosine is negative 1 over root 2. Again, we are finding an angle. This means find an angle. Alright, so what's going through my head? Monica, you got anything going through your head about where I should draw my pictures? Okay, well, you got to think about what's cosine. Cosine is x over r. So if you want that negative, you got to look where x is negative. Yep, 2 or 3. So now I'm drawing them here. And I know cosine is negative 1 over root 2. That should pop into your head how big this angle is. That's a 1, that's a root 2. It's got to be a 45. So your answers are this red angle right here. Go till you get to the radius, hypotenuse thing. That's your angle. How big would it be? $180 minus 45, which is 135. Kids, use your common sense. To my hand would be 180. But I didn't go all the way to 180. I stopped here, which was 45 degrees before 180. What about the purple one? It's all the way around. 180 plus 45, which you're right, 225. That's exactly right. Nicely done. Okay, let's do this next one. In which quadrant is the sine positive and the cotangent negative? Oh my Lord. Well, let's not leave that one blank because there's only 4 choices, right? So you got a 25% chance of guessing right. And the fact that cotangent is negative takes out the first quadrant. Nothing's negative in the first quadrant. So now we're down to 3 choices. We're going to look at the second, third, and fourth quadrant. Does my logic make sense to everybody? I want to know which quadrant, and I know it's not that one, which quadrant has a sign that's positive and a cotangent that's negative.
It has to be quadrant 2.
Has to be quadrant 2, Max says. Now, I'm going to go ahead. If I have a point over here, it's negative comma positive, negative x, positive y, negative negative, positive negative. Those are my SIGNs of my points. Now, if the sign is positive, isn't that y over r? That means y has to be positive, right? Wait a minute, looking at my options, that's the only place where the sign is positive. Now, it's also positive over here, but I ruled this one out because everything's positive over here, right? And I wouldn't get that negative in there, so I know it's not that one. So I think that's the answer. Well, let's go ahead and check on the cotangent. What's cotangent? X over y. Now wait a second. Didn't you already tell me y had to be positive? So if that's going to be negative, but I know y is positive, doesn't x have to be negative? Now it's also negative here, but the y is a positive. So when Max said it has to be quadrant 2, he's exactly right. He's exactly right. All right, can I get this page done? Let's see. Sketch one period of the following. Oh, well, we'll find out how well you know this when I grade your papers. But let's go through it and see. Oh no. Did you hash 1, 2, 3, 4 when you do your cosine?
Yeah.
It's a positive cosine. So did you draw it in like this? These are 2/3 and negative 2/3. These are supposed to be 90, 180, 270, and 360, but they are being divided by a 4th, which is timesing by 4. So 360, 720, 1080, 1440. Now, this was not your quiz question, I don't think. This, but there was one like it on the quiz, so you had to do what I just did, you did here.
Yeah.
What is my period then?
1440.
1440 degrees, and my amplitude is 2/3. Anybody have a question about that?
Will you turn off the degree sign? The degree sign on the test, on the quiz?
No, but let's get in the habit of doing that. Okay, y equals 2 tan. All right, now tan's different than cosine. Tan has an asymptote, and a dot at the origin. Now we're going to put a squiggly line in there. It is a positive tangent, yep, So we're gonna do a regular tangent, that means it squiggles up. So far, so good, Magnus? Now, these are supposed to be negative 90 and 90. That's what they're supposed to be. Oh, wait a minute.
It's 45.
Wait a minute, wait a minute.
Nothing's changed.
Nothing's changed. So they're at negative 90 and 90. What about that too? Don't worry about it. It's a tangent. I don't have any labels here for it to affect. So I'm done. That's it. What's my period? 180. What's my amplitude? 9. It's a tangent curve.
Darn it.
One more.
Oh, I messed this up.
One more. Here we go. Negative 3 sine 2/3 x. We are not going to psych ourselves out because there's a fraction. We are grown-ups. We can handle the fractions. All right, now, this is a sine curve, which means it starts at the origin. However, it's a negative sine curve, which means instead of going up, it goes down. So, here's my sine curve. There it is. I know this is 3 and negative 3. These are supposed to be 90, 180, 270, 360.
Increase by 50%.
But I'm dividing by 2/3, which means I'm multiplying by 3/2. So I have 270 over 2, which is 135. Now, if you want to do the same arithmetic for each one of these, so you would take 180 times 3 over 2, you can do that. You can also do it by addition. Since that's 135, this one's going to be plus a 135, so it'll be 270, plus a 135, plus a 135. So you can do it either way, I don't care. Whatever is easiest for you. What's my period? 540. What's my amplitude? 3. Very, very good. Now, then, I'll let you know tomorrow or the next day, or I'll put it in Power School too, when your test is going to be. We got a couple more days of review ahead of us.